Okay, let's have a look at this. We've got, given the pair of triangles are known to be similar, find the value of x. So we know these are similar. How do we know these are similar? So let's look at these two here. We've got an angle here and an angle here, angle and an angle. They're marked with an x. These are marked with a dot, so I know they're the same. So let's look at the sides. We've got a 3 and a 6, so that matches with that side. This matches with this side. So if I look at this one here, that's a 3 and that's a 6. 3 to get 6 is simply times 2. 3 times 2 is 6. And going mathematically of what we did before, that's 6 divided by 3 equals 2. So I know that that's a ratio of 2. So for this one, I go 4. What did I have to do to get that one? I know it's got to be bigger, and I know it's in the same proportion. So the same proportion is times 2, so x is going to equal 8. Okay, I'll let you do B. If we have a look at these ones, where's my little highlighter? If we look at these ones here, I've got to find out what this value is here. So once again, I've got my x and my angle here, my angle here, my angle and angle. So I know that triangle is similar to this triangle. So I'm going from the 2 to the 3. So let's have a look at that. I'm going to the 2 to the 3. So how do I do that? It's not obvious. So I have to do my 3 divided by 2 is 1.5. So now I know that this, sorry, hang on, I'll go. I know that that times that it's got to be 1.5 from this ratio here. So I know that it's 2 times 1.5 will get me 3 because I worked it out here. So now let's look at this one. And so I've got my 1. What have I got to do to get to there? So 1 times something equals x. What was my something? My something, because it's the same proportion, has to be 1.5. So if I go 1 times 1.5, 1 times 1.5 is 1.5, so I know x equals 1.5. Looks a bit messy, I know. Now, I'm going to do this example here. It looks a bit trickier, but really, it's 2 triangles in one. I've got this big triangle, which is that big triangle. I've just redrawn it. There was my little triangle. If I can take that out and just redraw it above it. So that triangle there is that one there. So it's still exactly the same as what we've done before. So if I look at this big red triangle, and I've got this, I know that's a right angle. I know they're similar. So I've got to look at this. I've gone from a big triangle to a small one, and I've gone from this side length to this side length. So how do I start that? So I can look at the ratio. So we need to get the proportion right. So if I look at the proportion of this to this, okay, or actually that way, I'm making it actually smaller. So doesn't really matter which way we go. Actually, this way might be the easiest way. So it's 1.2 times something equals 3.6. So how did we do that before? We put the big one there, 3.6 divided by 1.2. Put that in your calculator, or if you know it, it's 3. So it's that to get there is times 3. So something to get 6.6 has to be times 3. So x times 3 equals 6.6. Oops, 6.6. So what can that be? The other way to work it out is 6.6 divided by 3, and that's going to equal 2.2. So my x equals 2.2. Gee, it looks a mess, doesn't it? But hopefully it makes sense. So this triangle here, I looked at my ratios, so let's go over that again. Triangle here, this side length matched with that side length, that one matched with that one. So I did my ratio, 3.6 divided by 1.2, to find out what my proportion is. My portion was 3. So I know x times 3 will get me 6.6. So if I know that 6.6 divided by 3 equals 2.2, so my x value is 2.2. And there we go. These ones, which of the following triangles are similar? You've got to look for ones with the same angles and same ratios. So that's the hardest thing to find. So you've got to figure out which ones have got the same ratios and the same angles. I'll leave that one for you to work out. Okay.